My name is Oliver Buffole, and I'll be looking at mass spec, IR, carbon-13 NMR, and proton NMR to find the 3D structure of my molecule, which is 4-amino 5-chloro-2-methoxybenzoic acid. We're going to start with analyzing the mass spec. So the formula for my molecule is C8H8Cl-NO3. First, we're going to figure out the degrees of unsaturation, which is equal to the 2 times the amount of carbon, which is amount of carbon we have at 8, plus 2, minus the amount of hydrogen, which is H, which is 8 again, plus the amount of nitrogens, minus the amount of halogens, which we only have chlorine. That's going to be minus 1, all over 2. And for that, we get 5, which actually means we have a benzene ring and some double bonds involved. So my likely one benzene ring, maybe 4 double bonds involved in our molecule. 1 ring. Okay, and then we have to look at the mass spectrum. The mass of my molecule is around 201.6, and the base peak seems to be around 200.201 over here. And this little peak here could possibly be the M peak, but it's pretty small. That tells me my molecule didn't fragment very much. If I try to take some of the fragments out, I see 184 here. There could possibly be some sort of 17 here. Could possibly be an OH group that left. But the molecule, there doesn't seem to be much fragments that I can recognize off this molecule here. For example, I can try to get maybe perhaps ACL was in here somehow. Perhaps there's a possible CL here. So overall, I wouldn't say the mass spec is very useful here. Now we're at the IR spectrum, and this part can help us identify some possible functional groups within our molecule. So in zone 1, I know some large distinct peaks, which is like I think could be a possible sign of some sort of NH group. I think like the wide nature of this could possibly be a sign of an OH group that is kind of, the signal is kind of mellowed by some of the other functional groups here. I think it was zone 2 over here. This could be a possible sign, based on the short nature of this, of an sp2 hybridized, possible C double bond to C. With zone 3, I'm not getting anything. With zone 4, I see a large distinct peak, which is a clear sign of a C to a double bond to an O. And for zone 5, I see 2 distinct things over here, which is a sign of a benzene ring. And if we move on to the fingerprint region, and if you look at this, it says it's a possible sign of a C bound to a alcohol, like some kind of alkyl chloride. If there's a signal around 850 to 550, we see that over here. So this is a possible sign of a C to some sort of X, which could, in my molecule, is likely chloride. And go at the high H NMR to try to figure out the structure. So here I labeled the integration numbers 3, 1, 1, and possible 2 over here. And we can try to draw our molecule based off this. So I already said earlier that based off the IR, we likely have some sort of benzene ring. So I'm going to draw that. And based off that, and each benzene has a carbon on it and some hydrogens. You also need to account for the other molecules that we have. So we know we have some sort of C double bonded to an O, and we also have an alcohol. So our molecule may have this. and we see some sort of faint signal over here, which is a possible sign of an alcohol. And we know we have 3 alcohols in our molecule, and we see an ether here. So that means, and this thing over here is around the ether region. And we see a 3 over here, an English 3, that means 3 hydrogens. So it's possible that our molecule has an ether and a CH3 here, which matches with this signal over here. This part over here matches where I would see some sort of amide group if we compare it to this over here. So it's possible that our molecule has some sort of amide group over here, which will take away a hydrogen that I put in my benzene. And we also need to know that we have to account with some sort of halogen, which is chlorine in this case. So over here, let's just say we have some sort of chlorine over here. And these over here seems to be around the aromatic region, which matches over here with that part. So these can represent these molecules, these hydrogens. So if we draw, we should be able to label these with each of the hydrogen environments. It just like represents where the OH group would be. Since it matches around the signal over here, we can see that the OH group is very far out. Now we look at made up structure. Then we can look at the carbon-13 NMR to confirm our structure and the type of carbons that we have. So over here we see this molecule is very down left. That means very de-shielded. And in this sort of region, that we see some the oxygens and everything spawning to it. So that means that we can say, for example, it seems to be some sort of carbonic acid based on the position. So then we can say that the first carbon, number 1 here, is likely this one. And for our number 2, it seems to be around the 160 range, which is where that matches with the aromatic. So we can say it's over here. And for our number 3, it seems to be in the 150 range, which is still around where aromatic is. So, and closely to some sort of nitrile group too. So it's possibly this one. And for number 4, we see some sort of big jump. So that means probably away from the more electronegative molecules. And it's around the 130 mark, I'd say. So it's possibly supposed to be an alkene or aromatic. So I would label it as this hydrogen, as this carbon. And over here we see a 5 plus 6, and these are around the aromatic region as well. So I would label these as this one, as this carbon. And we see a number 7 over here, which is around 100. Again, still around where the aromatic region. So it's possibly this one. And we see an 8 here, which is the least deshielded, and it's really around in the region that where we would accept some sort of ethers or ethers. And I would say it corresponds with this carbon over here. And that's it for that. Go with me on this journey to figure out the structure of my molecule, and thank you.